Good morning, ladies and gentlemen, and welcome to the final week of the Semester 1 Plug Time Math lessons. You know my voice by now. I'm Mr. Wills. Please make sure that you have correctly written your name in the name line and that you have circled your teacher's name and the class that you are taking in the appropriate boxes on your worksheet. Now, before we begin today, I want to remind you that your job during this video is not to start working on the back side of your sheet. Everyone in your room should be on the front side of the worksheet preparing to go through these examples along with me. These examples on the front are essentially notes. You are supposed to be following along and writing down and taking notes on these examples. The reason being that I'm going to be explaining to you SAT style questions, talking about vocabulary, talking about things that come up that could trick you, trying to explain to you how the SAT is going to try to confuse you. And if you don't take these notes, then what happens is you go to the back side and you try to do those without these examples, and you make the mistakes that I'm trying to warn you about. So please, please, please make sure that you are following along on the front side of this worksheet and that you're not just going and doing your own thing. That is not what this time is designed for. So what we're doing today is we're solving linear equations. I know, you've done it all semester, okay, but again, we need to talk details. Okay, there are some things here that we need to make sure we are 100% clear on so that we're not making obvious mistakes. Now, when we solve a linear equation, that is essentially a four-step process. The first step is we need to get rid of all the parentheses by expanding, which basically is a fancy way of saying distribute. After we distribute, we are going to combine like terms on each side. Okay, on each side individually. We're not going to do all at once. We're going to combine like terms on the left side and combine like terms on the right side. Then we are going to isolate the variable. Which means x alone on one side. Doesn't matter which side, but we need the x to be alone on one side. And once we do that, we'll be left with a one-step equation where we divide in order to get x completely by itself. So, this first example is probably more complicated than anything you would see on the SAT, but not necessarily. Again, we need to be 100% fluid, 100% knowledgeable. We have to have mastery of solving linear equations. Okay? So when we go to solve this first equation, we start by getting rid of the parentheses. And the way that we do that is we take these negatives in front of the parentheses and we distribute them through that set of parentheses. So our first step is to do negative 2 times 7, negative 2 times 8x, negative 6 times 2x, and negative 6 times negative 7. So that would get rid of the parentheses and would leave us with 4 minus 14 minus 16x equals 12 minus 12x plus 42 plus 4x. So there we've taken care of step 1. We have expanded the expression and disposed of all parentheses. Now, the next step in this process is where many of you are still making mistakes, and that is combining like terms on each side of the equation. When we look at this equation, we should only be looking at one side of the equation at a time. So we would start by looking at 4 minus 14 minus 16x, which is the left side of the equation. And we would be looking for like terms, which would be 4 minus 14. So we would do 4 minus 14, which would be negative 10. And we would leave the negative 16x alone. Then we would turn our attention to the right side of the equation, which is 12 minus 12x plus 42 plus 4x. And we would look for like terms there, which we have 12 and 42, and negative 12x and positive 4x. So we would combine those like terms together. 12 plus 42 is 54. Negative 12x plus 4x is negative 8x. So this gets us down to an expression that may or may not have up to 2 terms on each side of the equation. So our third step is to isolate the variable, which means we need to move the x to one side of the equation and the number to the other side of the equation. Now I personally like for my x value to be positive, so I would start by adding 16x to each side of the equation, but you could just as easily add 8x to each side and you would get the same answer. Now since I moved the x to the right side of the equation, at the same time I'm going to move the number 54 to the left side by subtracting 54 from each side. This results in the equation negative 64 equals 8x, which we should all recognize as being a simple one-step equation where all we need to do to finish solving for x is to divide by 8. So we divide each side by 8 and we get negative 8 equals x, or x equals negative 8. Okay, again in example 2, it says what values of x satisfy the equation shown below. So we're following the same 4 steps that we just talked about. We're going to start by expanding, which means we're going to take positive 7 and distribute it to the x plus 1, positive 7 and distribute it to the x minus 6. So that would give us 6x plus 7x plus 7 equals 7x minus 42 plus 1. Then we look at the left side of the equation only and combine like terms. So we're looking for 6x plus 7x, which would be 13x, and then we still have a plus 7 on the left side. Then we go to the right side of the equation, 7x minus 42 plus 1, and we look for like terms. Well, on that side, what we have is negative 42 plus 1. So that gives us 7x minus 41. Third step then is to isolate the variable, get x alone on one side. So I'm going to do that by subtracting 7x from each side of the equation to move the x to the left side, which means at the same time I'm going to move the number to the right side by subtracting 7 from each side. That would give us 6x equals negative 48. And then we would divide that by 6 to get x by itself. And coincidentally, we get the same answer, x equals negative 8, in this equation as well. Okay, so that is the review portion of our lesson, talking about solving equations. Expand by distributing, combine like terms on each side, the left side and then the right side, isolating the variable by moving the x to one side and the number to the other, and that should leave us with a one-step division problem to do to finish the question. So now we're going to take that and we're going to take it a step further, which if you're in Algebra 1, you actually have not seen this yet. So this will be new, okay? And hopefully won't be too big of a deal. Okay, here we have another question. It says, what values of x satisfy the equation shown below? And this equation can look scary because it contains fractions. And we are not super comfortable as math students with fractions at this point in our careers. So here's what we do. We need to look at the denominators of these three terms. Now 9 is a whole number, so we start by putting 9 over 1 so that all three terms, all three pieces of this equation have a denominator. Then we need to ask ourselves, what is the common denominator of 2, 8, and 1? And the answer is that the LCD or LCM would be 8. All three of those numbers, 1, 2, and 8, divide 8 evenly. So 8 is the least common multiple or least common denominator of those three denominators, 1, 2, and 8. So what happens is we multiply all of our terms by that LCD. In this case, 8. So what I'm saying is we do 8 times all three things. Okay, so we do 8 times x plus 2 over 2 plus 8 times x plus 4 over 8 equals 8 times 9. Now when we do that, what happens is we are now able to carry out division. 8 divided by 2, for instance, in the first term here, 8 divided by 2 is 4. In the second fraction, 8 divided by 8 is 1. And then there is no division in the third one because it was over 1. So our equation becomes 4 times x plus 2 plus 1 times x plus 4, and no, you don't really have to write that one, equals 8 times 9, which is 72. This is exactly the same equation with no fractions. This process is called clearing the fraction. And that becomes the new first step in our process. So we would start by clearing the fractions, which again is multiply by the least common denominator. Then we would expand, just like we did before, which is distribute. Okay, so we're going to go in here and go 4 times x and 2, 1 times x and 4. So that would give us 4x plus 8 plus x plus 4 equals 72. Then we combine like terms on each side. So we'd start on the left side with the 4x plus 8 plus x plus 4. And we would ask ourselves, what like terms do we have there? Well, we have 4x plus x and 8 plus 4. So that would be 5x plus 12. The other side, there are no like terms because it's all one number, 72. Okay, then we need to isolate the variable, which means we want x by itself. Okay, so we would move the 12 by subtracting 12 from each side, and that would give us 5x equals 60, which leaves a one-step division problem where we need to divide each side by 5, and gives us x equals 12, which is answer D. So once again, this adds a step 0. Okay, the new part here, the part that you do not have experience with, is clearing the fraction. And that all comes down to recognizing the least common denominator of all three fractions. Okay, so on the back are 2 examples like examples 1 and 2, and 2 examples like example 3. Now is when you're supposed to turn your paper over and attempt those problems on your own. Again, hopefully you've taken notes here on the front and can use that example, example 3, to help you work through the bottom 2 examples on the back. Thank you very much for your time and attention.